Hello and welcome to the Blaspheming Bite. If you like this tutorial, please like the video and don't forget to subscribe and hit the bell icon. Okay, let's get started. The problem we're going to look at today is called the palindromic decomposition of a string. I don't know why you have to make it sound so difficult. If you check out Leetcode, the question is called palindromic partitioning. So basically what you're saying is, when you go through a string, create a partition whenever you find a palindrome, as simple as that. Now an example, let's dive right into it. An example would be A, B, A. Now one of the palindromic decompositions of this string would be A, B, A. Now for all practical purposes you could say that A is a palindrome, B is a palindrome, and A is also a palindrome. But you could also say that ABA would also be a palindrome, right? So these two are the answers that we're going to get. A, comma B. So let's have a notation. Let's say we're going to say the palindrome decomposition would be something like ABC. Let's call it partitioning. Decomposition is a big word. It's a fat word. I can't say it properly. So ABC, and then you have another one, AB and A. So this is what your output result should look like. Partition along. Now let's look at another example, and that should help us look at how we can do this in code. As always, I will put the code in my GitHub page, possibly my GitHub page. From today's class, I will try to point you to the Leetcode question as well. Looks like that's very popular. I mean, if you want to test out your code, where do you go? Go to Leetcode, right? Now let's look at an example. Let's say we have A, B, and C. Okay. Now I'm going to go directly into how we're going to do this, and then we're going to walk back and see how we can put this into code. Sounds good? How I'm going to do this is, I'm going to look at each and every character first, okay? Which means I'm going to look at substrings which have a length of 1, okay? So when I do that, what do I get? So this is when I look at, let's say I start over here, my position is here, and I'm going to look at substring of length 1. And is that a palindrome? Yes, that's a palindrome. So what am I going to do next? I'm going to add this to some string, and then let's just put, I don't know, something to partition the string. All right. Next thing I do is move my position so that it starts from the next guy. So if this were a recursive call, you would say position of right now that came into my function just added by 1, right? So position plus 1, and you're still doing the substrings of length 1, and then is that a length 1? Yes. So you're going to add B to it, right? Next, you're going to continue doing this. I'm going to do one more, and then I'll just fill it up, the whole thing, okay? Your substring length is still 1. What are you going to do? You're going to put an A there, and then you're going to do a B, and then you're going to do a C, and then you reach position equal to, position which is equal to the size of your input array, okay? So that, remember this, we're going to use that in our recursive formulation or recursive code, because I don't do recursive formulations, which I should probably do. Makes it easier to understand stuff. But anywho, your position, when it reaches the size of the array that you've been given, that's when you kind of stop. So at that point, what you're going to do is your result array, you have to add this to your result array. Okay, so that's the part where you've reached the end. Now let's do a little bit of backtracking. Okay, keep that in your mind. So right now my position is, where's my position? My position is here, and the length that I'm looking at is just 1. Okay, now I come back to C, and then I want to do a length of 2. Is that even possible? That's not possible, right? At this point, is that possible? No. So I don't even bother doing that. Okay. Now, is there any point in doing 3, 4, 5? Because there's nothing there, right? You're just going to hit a wall. You're going to hit a goddamn wall and come back. So once you've reached that position, like towards the end, you don't have to keep going, right? So let's go back now. Okay, you come back, you make position is back to B. Okay, and then what are you going to do? You're going to see length of 2, because you've already done length of 1, and that's how you reached all the way till the end. Let's do length of 2. What happens when you do length of 2? Now at this point, you would not have, you would only be till here. Okay, you would not have reached your till the end, so you're removing all that thing out of the substring so far, so to say. Length of 2, and now you go and check, is BC, shout out to all my Indian BCs out there, if BC is a palindrome, what are we going to do? We're going to add it here. Okay, and then we're going to keep going, but unfortunately it's not a palindrome. So we come back, and then we go to, where do we go? Go back to A. We go back to A, and then we check length of 2. Is AB a palindrome? So at this point you come back here, and then check, is AB a palindrome? No, it's not a palindrome, right? And then you go and check length of 3. So what would that give you? That would give you ABC. Is that a palindrome? No. So what do? You change your position, and so you get that out of the way, and then your position is over here. Okay, now let's check. So position length 1 is already done. Length 2, is BA a palindrome? No. Is BAB, so you've exhausted doing 2. Now let's do 3. Now is BAB a palindrome? Yes. So what are we going to do? We're going to add BAB into the thing, and then where do we move our guy? We move our guy over here, because we've already extinguished all of that guy. Okay, so in your recursive formulation you would do something like pos I minus pos plus 1, so your position changes based on that. Sounds good? And then what happens is you check C. Is C a palindrome? So when you do that, you're going to do length 1 again, and so you get C. Okay, now let's go back again. Let's go back to B again, and then just for completion's sake, we're going to do length of 4. Is BABC a palindrome? No, it's not a palindrome. So what do? We go back to position A. We come back here. That's our position. Okay. At this point, we've already done 1, so let's do 2. Is AB a palindrome? No. So we go and check 3. Now is ABA a palindrome? Yes, it's a palindrome. So what do we get? You get ABA, and then you put something like that. Okay, and then what happens? You go here, right? Your position would move here, and then you do the 1 and 2, and then you get B, and then you get C, and then at that point you put that back into your array. And then let's go back. Okay, we are not done yet. Can we do, let's do length 4. What happens when you do length 4? A, B, A, B. Is that a palindrome? I mean, it kind of looks like a palindrome, but it's not really a palindrome. So it's not a palindrome. So we scrub that out. Oh, position was back at A, by the way. Okay, and then finally we do length of 5, and we get A, B, C, which is not a palindrome. So in this example we got 3 guys. We got A, B, C, we got A, B, C, and we got A, B, B, and C. So those are the palindromic partitioning that we are doing here. Now let's look at the code a little bit. The base case is kind of simple. If you've reached the size, if your position is equal to the size of your array, what are we going to do? You're going to push the value to answer. Okay. Now if that's not the case, you're going to do a for loop. Now this for loop, the significance of this for loop is to check the size, to check palindromes for size 1, 2, 3 and 4. So what we're going to do is we're going to start from position, like I is going to start from position, and it's going to go all the way up till the size, and you increment 1 by 1. Okay, so what happens here is, let's say that your position is 2 and your size and the value of I is 2. So you will start with checking if the value, the substring which starts at 2 and ends at 2, whether that's a palindrome, and then in the next for loop you're going to check if the substring that starts at 2 and ends at 3 is a palindrome, if the subset starting at 2 and ends at 4. So effectively what are we doing here? Here we're checking 1 length. Here we're checking 2 length, 3 length, and so on and so forth. So that's the purpose of this loop that's on the top. Now within that you need to do something else, right? Once remember when you found a palindrome, so if it's starting like my position and my I are the same value, I did find palindrome, so I want to shift my position. Remember we were shifting the position of the guy A, B, C, and I had put something called position here, and that kept shifting every time I found a palindrome. That's the important thing to notice here. So if the substring that is starting from I to pos minus I minus pos, starting from I to I plus 2I plus I minus 2I minus pos, if is a palindrome, if that is a palindrome, then what do? you're going to shift your position by, you're going to call this helper function. I just call it a helper. Everything is just a helper, bloody help. And the helper function will get shifted by position plus 1. So if I was starting at this position here and my length is 1, yes, so this is a palindrome, just move forward and then start your start the helper function again, starting from position plus 1. So you're just shifting it by 1 and then keep doing it again. Now that's pretty much it, how you can do this question. There's really nothing else going on in this question. This is a medium question on Leetcode. It took me a while to understand and be able to explain this to you. Now, if you were given a simple question to just find all the palindromes in a string, that would be a pretty straightforward problem, right? So let's say given A, B, C. I think it's timed by some new markers. A, B, C. It's pretty simple, right? You start from this position and then you check for length 1, right? And then so you get A, B, C. You get all of those guys. And then you do length 2 starting from here, starting from here, starting from here, starting from here, starting from here. So at that point, do you have anybody? You don't have anyone, right? A, B, no. Then you go and do length 3, and then you do, can this be a palindrome? Can this be a palindrome? Can this be a palindrome? And can this, no, we're out of bounds. So that would have been a pretty straightforward problem. So 3 things to keep in mind when you're doing the palindromic decomposition of a string. Number 1, you need to reset your length at every point. So every time you find a palindrome, just reset it and then keep trying to find guys with length 1 and then guys with length 2, guys with length 3, and then just keep going like that. That's the first thing, okay? Reset the length to 1 when you find a palindrome. That's one thing that you need to notice, okay? Second thing, push your position forward. Push your position by 1 whenever you find that you have a palindrome with you right now. And the third thing is kind of insignificant, so I'm not even going to waste my time doing that, is when you've reached the size, you basically push it back into the result array. Now the code is going to be on GitHub. Please make sure to check it out. You can try it out on Leetcode. Pretty fun problem, a little bit of thinking to get to where you want to reach to find the answer. Anyway, hope you had fun. Have a nice day.